So this is a simple example which I used to discuss with every batch before I formally go in detail. So give you the importance and the of voltage regulation and the power efficiency. This is the simplest example. So let us say a very simplified example. 1000 megawatt power plant has its output voltage transformed towards a negligible loss and power sent out over 100 kV transmission line. So the capacity of your power plant is 1000 megawatt and it is transferring that power through a transmission line of 100 kV. So you know that the P is equals to VI. If we do not consider the power factor or we consider power factor as a unity, then the line current is P upon V. So I will be P upon V. So 1000 megawatt divided by 100 kV, this equals to 10 kilo ampere. This is the line current of this transmission line. Suppose the lines are too large, copper or aluminum couples, because we are using our transmitting power through a single phase system, single phase transmission line. So definitely you will be having only two conductors, and you know the conductor can be copper or aluminum. So inshallah we will also discuss, but at the moment we know the copper is the base, but again the cost of copper is very high. So nowadays throughout the world there is a trend that we have replaced aluminum conductor, copper conductors with the aluminum. So what happens, whatever, either you are using copper or aluminum, the total power of 2% is loss. So we are actually going to transmit 1000 megawatt, but 2% is loss. So the 2% of 1000 is only 20 megawatt. This is lost either in the form of heat, whatever. So at the load center or at the load point, you are receiving only 980 megawatt. So this is again the efficiency aspect of your transmission line. So you must try to bring this 1000 megawatt as it is to the load point. But now because of the 2% losses in the conductors, you are having the reduced capacity. So, but the current remains 10 kVA, but the line voltage falls along the cable length because you are having this 10 kV kiloamperes. So now the voltage drop. So now you calculate the voltage drop reference to the power loss. So 20 megawatt divided by 10 kA. So this again voltage drop of 2 kilovolts. So again instead of receiving 100 kilovolt at the load side, you are receiving only 98 kV. So dear student, this is actually what we have or we want to discuss about the voltage regulation issue and the efficiency. So when we are going to plan for a transmission line, we must consider these two aspects. So you know, line parameters have a very important effect on both efficiency and voltage regulation. So you must try to control those line parameters. So if those parameters are controlled, so definitely we will be succeeded or we will be getting maximum efficiency and we will be getting reduced voltage regulation issues. So definitely when the consumer, the end user is receiving or will receive same voltage, they will be having no problem. If we are getting the maximum power, so that power can be provided to maximum number of customers. If your power is lost, so means their capacity is reduced. When capacity is reduced, means you cannot accommodate a large number of users. So that's why when you are going to plan for a transmission line, you must consider these two aspects, the most important aspects and the parameters, efficiency and voltage regulation. So this is simplest example which I could discuss with you to understand the importance of efficiency and voltage regulation.